like to explain to you today are the differences between the power coat nut and a bearing nut. And to do this, we'll need a tool holder, a collet, a bearing nut and a coated nut, and a simulated shank that we're going to be trying to twist inside the collet to demonstrate the holding power. The bearing nut, as you can see here, is a 3-piece nut. It has an outside diameter here, it has the bearing race, and then all the series of ball bearings. Some of the problems we've seen in using the ball bearing nuts is the constant bombardment of the dust and dirt and fine particles getting inside of this bearing nut and actually seizing up the bearing. So right now I'd like to test the holding power of the bearing nut by placing the bearing nut onto the holder with the collet and a simulated shank. I'm going to tighten this bearing nut to 70 foot-pounds. I'm going to torque it down until it clicks, and then we're going to test when this is going to break loose, and then we're going to do the same thing with the coated nut. Okay, we've torqued this down to 70 foot-pounds, and we're going to bump this up to about 100 foot-pounds. Okay, then we're going to measure when that's going to break loose. As you can see, that broke loose around 100 foot-pounds. Okay, now we're going to compare apples to apples, and we're going to disassemble this. We're going to use the same collet and the same shank, and then we're going to use the coated nut. The benefit of this coating is it reduces the friction between the collet nut threads and the collet holder threads here, and then it also reduces the friction between the collet and the nut. Now we're going to insert the collet into the tool holder, and we're going to put the same shank, same collet. The only thing we change is the collet nut. We're going to reduce the torque rating here to 70 foot-pounds, just like we did with the bearing nut, and we're going to torque that down, and then we're going to try to simulate when this is going to break loose. Now we've got the torque wrench at 110 foot-pounds, a little bit more than the bearing nut. Let's see if it holds. Oh, now it's already better, so let's bump it up to 135 foot-pounds. You can see it's still holding there. Let's also increase it to 145 foot-pounds. Let's see if it breaks loose there. As you can see, it just barely moved on the 145 foot mark. So around 140 foot-pounds, it's about 40% more holding power for the coated nut versus the bearing nut. So the benefits additionally to the coated nut are, once you get to all your holding power, that increases the rigidity of that shank to the collet and the tool holder. That rigidity translates into more tool life when you get into the rougher cuts on your CNC router. The additional thing that I think is the largest benefit to the coated nut is the safety. Safety is something we all think about every day inside the shop because we have a lot of moving parts, and the last connection in the world that you want to come apart is this collet nut while it's spinning at 24,000 RPM. So the investment of a torque wrench and a stand and a Techniks coated nut was one of the safest investments that you'll make on that CNC router.